Okay, so one thing I wanted to go into detail about is potentially using these tools to set up both a design scenario and a fabrication scenario. So in this case, I'm going to do a mesh simulation that's sort of relaxing the mesh, but also sort of building in some embedded logic so that we can unroll these services, potentially cut them out on digital tools, and then put it back together to be able to make these services. Okay, so I made an initial mesh which kind of looks like that, and it's nothing special. I just sort of built it out of standard pieces. So taking a mesh, sort of making the X, Y, and Z count 1. You can sort of make these elements. And then you can start to add them together in some way. So what you want to do is make these open tubes. So that you can join them together. So I'm just deleting the ends of these. And I can join them back. And then the other thing I want to do is join these center vertices together to make a single sort of connected mesh. So now one thing I can do is that I can connect, this mesh, this point to this point, this point to this point, these around there, and then you'd end up with a little triangle in the middle of it. So instead, I'm going to rotate these roughly 45 degrees. Doesn't have to be exact, nor does it really need to have any particular shape to it. And then I'm going to connect the tops. And then I can turn on these points and say this point, I'm going to stretch over here. This point, stretch down there. And what's left is this open side that has 4 sides and 4 points, which then this can then match up with. So if I take this point, put it down there, this point, so I'm just stretching this around, trying to join them together. And what you end up with is a sort of closed joint of a mesh that I can group together into one mesh. And ideally you want to put it together in a way that each vertice has an even number of points, even number of faces. So 1, 2, 3, 4, 5, 6 around this one. You should have 4, 6 on the bottom. And so that works out roughly the way we want. And so I've just made a more complex version of that. At the other ends I would add more. So you could have 4, 3 connecting, however many you want. And so this is not a pretty model. It's really just meant to set up a topology. So topology sort of says this face is connected to this face is connected to this face, but we don't so much care about the geometry. We're going to use Kangaroo to sort of change that geometry later on. So let's start to refine this mesh a little bit so we can use Kangaroo. So we're actually going to use refine. And so what it does is it starts to subdivide this mesh a little bit more. So it cuts it down. Then we're gonna make sure the mesh direction is the same everywhere. So mesh direction. Let's see where that is. Mesh direction. That sort of aligns all the faces together in the same sort of orientation. Since we built these separately, it's quite possible that they might not be sorted in the same sort of manner. So that sort of starts to align them a little better. And then if you need to, these seem to be aligning correctly, but in some cases you might want to turn the mesh directions if we need to subdivide it in a different way. So that's the next thing we'll do. After that is sort of create some strips. So in this case, we're going to say how many times we want to subdivide these things. So we can subdivide them more or less. And this is setting how smooth some of these geometries are going to get. So if we don't have the mesh turn, you can see that these are aligning into very long mesh faces, which is not going to bend very smoothly. We rotate these around and we have relatively similar small mesh sizes. Now we might even go back to this and subdivide it more, and that would build more strips that we might have to cut out later. I'm going to keep it relatively simple like this. Okay, so from that model, we have the topology set up. We just need to be able to relax this and then unroll it into buildable strips. So I want to split this up. I'm gonna say get a warped weft sort of component. What this is gonna do is sort of split these into directions. All the edges going this way and all the edges going this way. So that allows us to separate these out. We can say we're going to make springs in both directions so we can change them independently. So under line length control, we can set one side. And you can see the ones that are going around this way, we'll set with one strength. And the ones that are going along will set the other. So if you imagine these were tight cables and these were loose cables, we can make it bigger or smaller when we relax it. So we can set those up with slightly different numbers. So I'm going to say 0, 1.0. And this one I'm going to set to a lot higher. Let's set this one to $1,900. Okay, so one is going to be a lot stronger than the other. So the other thing I want to do is I want to try to make sure that each one of these mesh faces tries to stay as planar as possible. So that's going to allow me to unroll it fairly easily once we've relaxed it. And so I'm going to set that to a pretty high strength. I want them to be as planar as possible. We'll go ahead and plug this into our Kangaroo solver. You see it's starting to relax a little bit. Now the other thing that we want to do is, well, let's visualize that mesh instead of these lines. Visualize that, and entwine these. Just get the mesh out. And then we'll be able to reset it. Okay. So now we have our mesh sort of set up. We'll want to control it slightly more than that so that it's not this sort of wrinkly mess. So I'm going to get the mesh edges, which will basically give me these points. Now I want just the naked edges, the ones that we left open. I'm going to make sure that these are joined together in case we didn't join them before. And then I'm going to explode them so that I can use the vertices and the segments of that curve. So what I want to do is basically set up some sort of point that this is going to pull this mesh to it. So right now it's able to just move around. It's not really controlled. So if you imagine if these were tied to something, they would pull tight. So I'm going to take these vertices and I'm going to approximate a circle or fit a circle around there. So you can kind of say it takes those points and makes kind of a circle in that plane. And then I want to pull all of these points to that curve. And let's give this something high as well, like 10,000. So if I add that to our goals, let's reset it. These are now locking in place a little bit, and they're also circular on the end. So one thing I want to do is I'm going to set the length of these now to be 0. And what that's going to start to do is pull them as tight as they possibly can. Now, since these are set really high and these are set really low, they're going to pull these almost straight. I'm going to make this a much higher number now. Or 10 actually. 10 gives it slightly more pull. Let's reset that. Now something you can see that's happening is that this one over here, all these points are still on this curve, but it's not staying fully open. You have some that are stretching out and some that are collapsing down. So let's see if we can create another sort of criteria to fix those in place. If we were to say make all of these segments in equal length, instead of one collapsing down and another becoming large, they would try to all maintain the same length. So I'll make that somewhat strong. And let's reset that and see. So now instead of sliding around, they all stick to the edge of that. And this is kind of chunky. So let's see if I can turn this up and we can actually thin it up quite a bit. And so you get a pretty nice smooth shape, same sort of topology that we built from the original mesh, but this is starting to refine itself a lot more. Okay, so once we get that out, this is going to constantly update, so I'm going to make a data dam. Every time the data changes, I'll have to update that and it'll send it through. That in case, if I update this again, it'll tell me I need to update it, but it won't send it every time that this changes. You can see once it's converged, it doesn't send it through again. So I can use that to not change the data that's flowing through to something downstream that maybe takes a lot. So what I want to do is, with all of these mesh edges, I can now sort of unroll, or I can turn them into strips actually. So I can take this mesh, turn them into strips, and it basically just finds some that are connected in an easy way. So this broke it into 24 of these strips. And then I can unroll these. So I'm going to take these meshes, and you can see that they start to fly out in space. If I put a slider on that, I can bend these back up to where they are, or I can open them up flat. And so since I built this in a way that all of these things are going to be planar, I can unroll them into planar sheets again. So this allows me to be able to sort of make these flat objects and lay them out so that they can be cut on a CNC machine or a laser cutter or something like that, knowing that they would bend back up into these shapes again. So I'm going to put another data dam here. I don't want that to update every time I send it through. Now each one of these meshes, sort of weird, oddly put in space in some capacity. So we need to figure out a way of getting those sort of flat. On sort of the XY plane. So I'll show that in the next video, so this doesn't get too long, and you can use this to convert your mesh assemblies into fabrication setups.